field expanded all the way across, probably covered all of Arizona, and actually blew into volcanic highlands, the great arc of southwestern North America that was forming at this time, the great volcanic arc terrain. And these dunes actually blow into the arc. And there's a couple places in eastern California where you can actually walk. You can walk through a lava flow and then an aeolian dune and then through another lava flow and actually see or experience, in a sense, the landscape of 190 million years ago. It's really quite astounding to see interbedded lava flows and wind-blown sand. In the Middle Jurassic, the sea returned to Arizona, came down from the north. Jurassic, by the way, the term comes from the Jura Mountains of western Switzerland, and where it comes into France, Lake Geneva area. Anyway, the sea comes down from the north, and this sea originated all the way up into the Arctic. And so you know how far that is up there. It's way up and over that way. I hope we can put some of these up there. The sea comes down through this tremendously arid landscape already. And as it evaporates, salts are going to precipitate out, particularly along the shoreline and in these embayments and so forth. And an example of this, if you know where the little town of Salina, Utah is, well, what does Salina mean? Salina means salt. And what happens at Salina, Utah is one of the largest gypsum plants in the Southwest. So most of your wallboard is probably coming from the Carmel Formation in Salina, Utah. So they're mining the gypsum, the evaporative salts, out of this Carmel Seaway. Meanwhile, to the east is this Page sandstone, another wind-blown sand deposit, exposed very well right into Page, Arizona. Another sequence of dunes and seas, the entrada sandstone, still in the Middle Jurassic, about 160 million years ago. Of course, the great arch former up here at Arches National Park, the entrada sandstone. It forms White Mesa in northern Arizona, if you know where that is. It forms the big cliffs when you leave New Mexico, or go between New Mexico and Arizona on I-40. The big cliffs along the highway there are in the entrada sandstone. Then maybe the second most famous geologic unit in North America, after I think the Navajo sandstone, and this is the Morrison Formation, famous as this is the real Jurassic Park. The great dinosaur graveyards of Dinosaur National Monument, although these are not the biggest quarries, they're the most famous. There's a bigger one over here, and now they're opening a whole bunch of quarries along in western Colorado here and eastern Utah. I did my master's up at Utah, and my professor up there told us that in his early days of doing geology in southeastern Utah, he said the fence posts around Blanding were the femurs of dinosaurs. You can imagine none of those fence posts are there anymore. And he wasn't a joking kind. I believe that story. Anyway, mountains were uplifted to the west, the rivers drained. Notice now the rivers are going off to the northeast and east. Before, everything was going this way. So the landscape is evolving. That's one of the points that I need to make, is that landscapes change over these immense amounts of geologic time. And so the streams ran to the north and northeast, and the dinosaurs lived along these streams and were buried by floods and so forth. Then comes the Cretaceous. The rocks aren't quite as pretty, but the geology is very exciting during the Cretaceous. A lot was happening in western North America and also across the Colorado Plateau. These Cretaceous rocks yield incredible amounts of fossils, everything from dinosaurs to ammonites to all kinds of shelled critters, and et cetera, et cetera. And one way you can do a little roadside geology in the Cretaceous pretty easily. This is a little dangerous, but you can do it. When you look at the Cretaceous, when you see these slope-forming units here and here and here, you're offshore. You're an offshore marine deposit. If you take the time and stop and go digging around in these deposits, if you look hard enough, you'll almost certainly find marine fossils. When you find the cliff forming or the ledge supercontinent was breaking apart, so we get all these mid-ocean ridges forming as the continents are moving apart, just like this is the mid-Atlantic ridge only about 100 million years ago instead of today. Well, ridges take up volume in the sea. The more ridges you have and the faster the ridges spread apart, sea level has to rise. It's like, this sounds stupid, but you can do it. It's like blowing up a beach ball in your swimming pool. If you do it, the water in the swimming pool is going to go up as you blow up the beach ball. I don't know why I think of that. But anyway, so as these ridges expand, sea level expands, and it inundated much of North America. Europe was literally water world, North Africa, incredible expanse of the sea in the Cretaceous. And this deposit right here made news in northern Arizona not long ago when Dave Gillette and a team of geologists from the museum found a dinosaur about 80 miles offshore in the tropic shale. By their calculation, how a dinosaur got out there, they're still trying to figure out. But anyway, it certainly didn't live there, but probably was somehow washed out into the seaway. And a lot of the fossils are you can see in the Museum of Northern Arizona from these localities here. Same name or the same unit in Colorado as the Mancos Shale, named after the Mancos River in the town of Mancos here. And then the shoreline deposits through Arizona here are called the Dakota, and it's exposed just north of us around Tuba City, and also right at Sholo. Through Sholo, these deposits are exposed. In fact, I remember one time being desperate and stopping hungry, stopped at McDonald's there in Sholo, and I found a fossil right in the parking lot there in the Cretaceous sands. So it wasn't very good, but it was there. So anyway, these seas came in, mountains to the west, the interplay between the uplifted mountains, the rivers building sediment into the sea, and through time what happens, the rivers prograde or advance out, cause the shoreline to retreat. And in this retreating shoreline was formed this huge mass of sandstone like we saw at Mesa Verde. And of course the Paleo-Americans lived in the niches underneath this sandstone at Mesa Verde. The cliffs at Mesa Verde are formed from this shoreline sandstone of the Mesa Verde group. I think you can guess where that name comes from. So anyway, if I were to show a complete sequence here, I'd show the sea going back in and out 12 or 15 times. I'll spare you that and just tell you that happened, and we're just going to show the retreat of the sea for the final time, covering all of the sea left, and rivers covered all of southwestern North America. But a very interesting thing happened about 65 million years ago. We start to see the very first uplift of our Rocky Mountains. And this was signifying the great change of the Colorado Plateau. Virtually all the rocks I've been talking about, with the exception of the Vishnu Schist, all the rocks I've been talking about formed at or near sea level. We saw the seas in, we saw out, we saw coastal dunes, we saw coastal rivers. Well, this is about to change because the whole region is going to be uplifted. The short, quick answer to this is a thickened piece of ocean crust collided with western North America and caused the entire Southwest to respond to this collision off the shores of California at that time. And that actually is thought to have triggered, started the mechanism that triggered the uplift of the Colorado Plateau and the Rocky Mountains. Probably coincidentally, although some might argue differently, this of course is when the great meteorite hit in the Yucatan Peninsula, and may or may not be the final cause of the extinction of the dinosaurs. So now we're going to go into the Cenozoic, which is typically divided into two geologic periods, the older Paleogene and the newer Neogene. The Paleogene was the uplift of the Rocky Mountains, as we can see here near Silverton, Colorado. The tilting of rocks, for example, here at Dinosaur National Monument. A large number of volcanoes formed across the Colorado Plateau. Not our peaks, they're much, much younger. But the Henry Mountains, for example, or the Abajo Mountains, or the La Salle Mountains, they formed about 50 million years or so ago as volcanoes.